15 different people that wants to show the use of IFC. And unfortunately, we had to say no to even more people that wanted to show what they can do. So unfortunately, we can only show a small selection of what is possible to do today. And what we decided to do then was, instead of showing the same software from different vendors, we decided to try to illustrate how much we can do from the early phases and down to facility management. And I would like to also introduce my very good friend. He comes from about 12,000 kilometers this way, from Australia. Mr. John Mitchell,
Thank you.
Please introduce yourself.
It's great to be here. We've done this before in another time. I've never seen such an amazing array of applications, and surely this will be a really big test of your confidence in what you expect out of IFC.
Yes, actually we are more worried that we don't, this list contains the number for each PC and how it's connected to these switches. And I guess that's the major challenge here, to get this to work. But if you guys are ready, I think we can just start. And I'd like each of the participants here to present themselves and the company. And I think this is what we have been through. I think we'll start with Bjørn Lura from the company Powell. There's supposed to be a microphone there.
Hello? Oh, that's nice. Can you hear me? Good. My name is Bjørn Lura. I come from a company called Powell Gemini. And we are a software provider. We are delivering GIS software. And my major software application is terrain modeling, which I will show you here today.
6. Can you press 6?
Okay. Wow!
Am I on the air now?
Yes.
Okay, okay. During my demo, I will show how the Gemini software can act as a glue between the GIS and the CAD world, using, what was the format name again? IFC?
Yes.
Okay. Okay. I start with a zoning plan. A zoning plan, whenever someone wants to build something in Norway, there has to exist a zoning plan for the area. We call it a reguleringsplan in Norwegian. If there's no such plan for the area, the builder must take the economic cost to make such a plan and apply to the authorities to get an acceptance for this plan. I believe that is quite similar in most countries for the representatives here. The Norwegian authorities has for many years been offering digital maps in a format called SOSI. And the Gemini software can get an existing plan from the authorities using this format. We will also be able to get these kind of plans on the IFC formats. If there is not such a plan in the area, we can use our software to create such a zoning plan. And that's really why we are into this, because we want to be able to deliver these plans to the ByggSøk project. This, what you see here, is a zoning plan from Oslo City. Basically, a zoning plan is a set of non-overlapping polygons having a property called planned purpose. This one, for example, is this is where the Munkerud building is going to be placed, or perhaps it's already placed there.
Yeah, there's people living in it.
And they don't know
But
about...
that's the proof that IFC works, but just to continue.
They don't know how famous building they have.
No.
It has the purpose of 110 in the Norwegian coding system, which means it's for residence or home buildings. If I look at another area, this one is for park belt in industry area. Obviously, you wouldn't put a building in here in the park, of course, and you wouldn't put a factory in a residence area. So that's what this kind of checking is meant for. You will also find, if I zoom into this area, a percentage telling something about how much of this area can be used for a building. I believe in English that's called something like a plot ratio.
Plot ratio.
Yeah. A zoning plan also has a set of juridical lines and polygons, which I show you here. This one, for example, is what we call a building restriction line. That means even if this area is planned for buildings, this is the place where the building must be inside. If you look at this value, you also see that it has a height. That means the height above sea level. So the roof of the building must not exceed this height. Now, let's say that this plan is created by me in my software. Then I want to hand it over to the Byggsøk portal to apply to the authorities to accept this plan for the area. So then I go to the export settings in my system. In this case, I want to export it as 2D objects. I select the export button and I enter name of the IFC file, call it zone plan. This IFC file may now be delivered by e-submission to the authorities through the Byggsøk portal. This will be demonstrated later, the Byggsøk. I will now just show you what this would look like in a standard IFC viewer. And for that purpose, I'm using the IFC viewer from the DDS system, which is, in this case, built into my application. So I'm using the same application. So don't be confused. You would probably have another application for a viewer yourself. And the viewers will be, probably, you can get free viewers on the net. Already now you can have that. So I open this zoning plan in a viewer. So this, perhaps it is not so impressive to look at the first sight, but what you now see is open to the CAD world. That is any software in the market that can read IFC files. And that involves a large range of house building applications, like for instance, Archicad, Autodesk, Architectural Desktop, DDS, Bentley, Revit, Allplan, etc., etc. I also show you that these are not just nice lines with colors. There is, in fact, information behind it. So you can see that this is a geographic element in the IFC file. You see who made this, who is the owner of the information, and you get the coding system. This is the building restriction line. If we look at the zoning area purpose, you can see that from the Norwegian coding system, it has been transferred to the IFC known PSET space common, and the name of the purpose has changed name to occupancy type. You also see the planned area of the zoning area, and you see the net planned area, which is 30% of the building that is to be planned. So this will be used of the checking software later.
I would just like to add a comment here, because this is a compliment to the Norwegian authorities, because this was not possible in IFC until the idea of doing this Byggsøk program was launched. So the Norwegian authority made a proposal to IAI if they were allowed to set up a project to make this possible. And they did. And this is today, and yesterday is the world premiere of the first software that can actually do this. But the interesting part is that this can also now be imported, as you said, into any IFC compliant software. I think that's fantastic.
Thank you.
So next part of my demo will show how to combine a design building model from the CAD world with a situation map, and then apply to the authority for a building permit. So I move into the situation map. It would look something like this. You will find a wide range of different map elements in this drawing, like a terrain model, water and sewage data. You can see manholes and pipes here. There are properties like this. If I look at it, you can see it's not just lines, it's information. Like, for instance, this is a property with a national identification system, which is called GID in Norway. This is a unique identification within the municipality. And you can also see that for a building. It has a building ID, and it also has a feature code. And it has a building type. These are existing buildings. In a Gemini system, we can switch between 2D and 3D view very quickly. So this is how it would look like in 3D. The terrain model is automatically calculated. You can see also the buildings. They are a bit simpler than they are in the CAD world because we only have the top roof line, the height of the roof, and we make an extruded surface down in the terrain model. I can make a rendered view of this situation. I can apply a sun or any light source I want, and I can also apply an air photo that I can put on the map. This is very simple 3D picture because I haven't done anything to the data. I just imported it from the SOSI world. Next thing I want to do, I want to put the building model into the system, and I apply also the zoning plan into the map to have a look at it. So, surprise for you, the architect that I'm collaborating with, he used IFC compliant software. So this building is designed, I believe, in ArchiCAD, and I already got it from the architect, so I just want to insert it in my drawing. Select the right file, and just put it in there. In this test case, I want to put the same house, I want to build the same house 2 places, 2 different sites. I just put them in, and the architect, he was kind enough to give me the coordinates where I should put those buildings.
While you're entering this, I would just again comment. First, we saw live a creation of an IFC file from a GIS system that will fit into any CAD system that's IFC compliant. Now we just saw the opposite. Now we saw an IFC file live be just imported into GIS system. Isn't that quite good when we start communicating between the different worlds here? So again, this could be IFC building from any IFC compliant software. I think that's good.
So planners can get access to building data. This is an extraordinary development, in my opinion. And the developers, the designers, the design team get access to the land and the infrastructure data. You know how difficult it is to do it today. It's wrong, it's inaccurate. You have to go to 16 agencies. One file of coordinated GIS data gives us the context of the building. This surely must be one of the big advantages of IFC. We really save time and we increase quality.
Okay, thank you very much. Now you see I'm quite satisfied with my placing of these buildings. I see I have perhaps a little too small space in this site, but anyway, I hand it over to the authorities to search for a building permit. So I want to export this as a 3D model. I enter the name for the file and export it.
So now we are combining IFC, both GIS, and so this is the yet another model with both terrains and 2 buildings.
So again, I go into the IFC viewer, which is In fact, another application. But the same in this case. Don't be confused, please. So, what you can see now is the information. You see the lines, of course, and also the information. This is a terrain model which has been made. Anyone in the CAD world can now read this, this file from us. And it has the coding telling it's terrain and it's outside. Yeah. Jeffrey knows about all this stuff. He can tell you. We also have a map. And on this map, we have 2 buildings. And we have all the objects in the building. We have access to all the objects in the building. You also find all the different map elements in here. So I want to have a rendered view of this file. Don't laugh yet, please. Please laugh afterwards if you don't like it. Okay, I can go into every...
Oh, this is, here you can see columns, slabs, rooms. This is spaces inside a building, so you can actually browse through the building down to the single building element placed in a terrain. That's quite fantastic.
Now, you also see, let's first take away the spaces. You see first where I put the building here. Both of my buildings, you can see here, put into the terrain model. If I want to show you the building restriction lines, I can switch them on. And you can see here that this house is completely inside, and this one has a problem. I can make those lines transparent to view it in a better way.
And the tool he is using now is just a viewer that could be freely downloaded from the internet. There's no special applications, just browsing the IFC information.
Don't you think that the local authorities having this tool will have a better way of making decisions about which house is correct placed? I think so. You see that this building, which is already built, he probably had to apply for a waiver. And so must this one. But perhaps, let's see if we can make some changes there. Perhaps, yeah, why not? We build a convertible Munkerud building instead, and then we apply for building permit.
Okay.
Okay. Thank you very much. That was all I had.
Okay, I was sure this was going to work, but now we're back to the switch problem again. So let's see. Next up is Jens Sjögren.
So I'm representing the Norwegian Home Builders Association, and what you see here is an application in Norwegian. We prefer that in Norway, but an internet-based project portal, and we are now online in this this project portal, and here we are. We've got the Munkerud House 7, that's our project. And this is an ordinary portal where we have focused a lot about standard documents like contracts and a lot of documents that our members and the building industry need to do, standardized documents. And but of course we can also upload IFC files and send it to IFC compliant software, and so this is a project archive. Among other things, we have made an integration to the Norwegian e-submission system, ByggSøk. So this is my e-submission archive as well. So I push this button, and then I'm suddenly inside another application online. It's the e-submission system. So there's a lot of things and information that we are sending over to the e-submission system, and we could have sent it to the local municipality, but as you see, it's not yet complete because we need some electronic signatures here. But that is what we not have done yet. So, but we could see we could generate. There is all things we did before with a lot of paper prints, but we are using this print. But I'm leaving the mouse to the Mr. Big Suck, or
Yeah, next one is up is Paul Huse from EPM Technology, and he will now pick up what Jens just filed as e-submission.
Yeah, just want to log out of this first and bring up my own. Because I've done some preparations. And also this one, we quit. So, in order to, complete the information needed to send this to the municipality, we need to fill in all the necessary or required information, and by entering information in forms like this, we can freely move in the menu, or continue using a next and previous button all the time. As we have seen, IFC file has been created for this Munkerud buildings, and I have already uploaded this IFC file. So it's now as an attachment in Big Suck. And Big Suck recognizes that the attachment is an IFC file, and prior to the application being sent to the municipality, it goes through a validation process. So it will actually check if the building is placed within the allowable boundaries, and also check if the purpose of the building is compliant with the purpose as specified in the regulations. And this validation takes a couple of seconds, so I have actually run it through the validation. So I have here, as Jens just showed us, a small document which is a condensed view of all the information in the application for a building permit, where the information for the site, for the responsible parties, for all the neighbors and such. And this here it says here's the attachment. It's the IFC attachment, which now has been validated. And as Björn showed us, there were two buildings on the site, or on two properties nearby each other, where one of them actually was placed outside the restriction lines, and whereas the other one was correctly placed. So all this validation takes place on a model server, which are integrated with the Big Suck system. So here you see one building violates the rules and restrictions, whereas the other one passes the validation without comment.
So in fact, I could build a convertible building.
Well, in this case, we didn't check if the roof was present. We checked if the placement of the building was within the allowable set of rules. If the validation came through with success for all, both for the application itself and also for the IFC file, then it could be sent to the municipality. I have here another one which I have run through, who has gone through successfully, now ready to be sent to the municipality. And by the click of a button, it's on its way to the municipality, where it will be processed further. And BygSøk is free of use, so please make use of it. Thank you.
Alexander Bjørland is representing the local authorities here in Oslo.
The municipality of Oslo receives about 4,500 applications each year, and the main part of these applications are paper-based. So we scan each of these applications, and each scan takes about 40 minutes for an average application. And as we will see now, I'm going to import the application from BygSøk. That takes only seconds. As you see, we have 3 applications here, and this one is from Paul. And you have to follow because these go quite fast. It's now importing and do the registration in the application handling system and connecting all the documents in the same system. There it's finished. This usually takes 40 minutes today when we get a paper-based application. We can see here on the documents, we can see the report from Paul, or we can just view the model, which is the same model that we have seen twice. So here he comes.
So we've been talking a lot about e-submission and automatic checking, but this is the manual also checking on the authorities side. So you now moved inside the local authorities here.
I'm not going to spend much time viewing this model, but I want to say one more thing, and that is we are returning a lot of applications each year. As you can see, we take about 4,000 applications, and we do return them because there is lack of essential information. And if you see here, this is the main, it's the top 8 lack of information. And almost every one of these reasons are possible to eliminate with BygSøk and with IFC. You can see incorrect drawings. IFC control is doing that, and all the incorrect situation map. So we're going to save a lot of time with this type of systems.
Good, thank you. And again, let's hope this works with the switches. We have now seen the zoning, the maps, world premieres, etc. We've seen BygSøk, Nyttbygg. We've seen how it looks on the authority side. We will now do the more things that we have seen parts of before, but also here's something quite interesting. We will not start showing you how to make an architectural model, but we will start with structures. And we start with Lasse Liflander from Tekla. And then we have to press 5, I think. Oh, how good is that?
I'm Lasse Liflander from Tekla Corporation, and I'm going to show the Tekla structures application here. And here I have the architectural model of Munkerud as a reference model. And I have filter it out the entities I don't want to see, like the terrain model and the roof. I want to see the beams and columns, the walls with doors and windows, and the stairs. The structural engineer can use the reference model, for example, for picking points and measuring distances. So all designers from different disciplines are designing the same building. All are able to view others' work on the model. Also, it can easily be seen if there are any clashes or design mistakes. So this kind of workflow shortens the design time and improves the design quality drastically. With the clipping plane, I can spatially adjust the viewing depth. I can have several clipping planes if I like. The structural designer can carry on the design by adding structural elements and details into the model.
Isn't this a revolution? Isn't this the way we should be designing? Who's drawing lines just to trace? We're designing now. This is getting very close to design.
I turn on the parts and reinforcement parts, and I modify the model. So you can see I have already added some structural elements into the model. I have here the foundation and slab panels for the part of the ground floor. And some of the footings here. Footing pads include the adaptive reinforcement. And the adaptive reinforcement means that if I change the size of the footing, the reinforcement will adapt themselves to the new situation. Like that. And now I'm choosing all the elements here, and I will export them to the rest of the work design group to carry on. Okay, thank you.
Okay, so now we will, what was that all about? I mean, now we will see how this information that he provided with his structure can apply to the architect. So now we have Odd Godestad from Arctis, the Graphisoft distributor in Norway. If we can get the picture here, it will be helpful. He is number 6, which should be 6 + 1. Yes, there's no signal. There it is. Okay.
There it is. This is the original architect's model that was developed and has been used by all those other people and disciplines you've seen. Others have added data and value on this. This model is also used by HVAC, electro, and all from the same IFC model developed from the architect. Here is the data I have received from the structural engineers, as you just saw. This now needs to be imported into the architectural model to show that everything fits and for further detailing. So if I go into plan view and go down to the foundation story, I can import that quite easily. There we have the foundation in the ArchiCAD model, and we can see it in elevations, especially if, okay, like that. In 3D, suddenly has grown foundations. And we can see that everything fits, everything is correct. It usually is when it's made from the same model. It saves a lot of work with redrawing and everything. So I can go straight into an elevation and see it auto-generates the foundations from Tekla. There it is. And I have drawings that I can continue to detail. Okay.
Okay.
So some of you may remember a year ago we showed a very early demonstration of the structural application. There we could only import a tiny IFC file. Today, 1 year later, we have nearly 5 structural applications able to support structural exchange, and we get that functionality that you see exemplified by Tekla. A fantastic rate of improvement in the availability of applications that support the whole process.
So actually, I guess you feel this is going a little bit fast. I mean, the presentation, we have no time to go in depth. Actually, we're running a little bit behind schema. But Thomas Leiner from Olof Granlund in Finland, he will now tell us something about energy, I guess.
Yes, you are right. Energy and comfort issues. So now my role in this, through this building process is now to make sure that energy performance and comfort performance are as required. And for that I use ground software Ryuska, and I have imported here the building model from Architect. So just to make sure that everything is okay, I can study, and for me, I can see those issues in the model that make sense for energy comfort analysis. Okay, you can see that actually the same time when I imported that I got already 80 to 90% of all the required input data. So first I go to third room and pick up one room, and from comfort point of view, we can see now immediately what would be the indoor quality, thermal quality based on regulations and codes. And we can see that it's very too high, and also analyze that through the whole year. So we can see that almost 25% of the whole year we are above the limit. Okay, so that means that we have to do something. And now I make a new solution just by copying the whole building model to another case. And let's try now something other. So for example, try to use better windows. So I copy the whole case, and now I can make those changes what I need, and for example pick that outside wall and those windows, and make a change for that. So I organize by technical values or the whole library and pick up one that's much better than those others. And let's change that. And now I make a new simulation. So, and in the same time, because those target values are specified, I can ask to size air conditioning systems so that fulfill those requirements. And now I'm making the whole year simulation based on those requirements and can see the comparison. So all of you can see now that at least we have a much better result in terms of indoor air quality. And we have optimized the window construction so our load from that is much less. But now, while I'm sizing all the systems, in the same time I get information about the energy efficiency. So I can take the whole building level and ask, please give me a report of energy consumption. So now I see what is the energy performance of the whole building. So including all spaces individually, no simplifying between. And of course, you can see, and I can see here, that lighting electricity is now the next point what we should make better, but perhaps not in this shown. So now what I do is actually I can deliver the new information to the same IFC model and to be used in ducting design. So I export those airflows to the next in the show.
Yes, thank you. So actually what he did, we are still using the same data here, the same IFC model. He enriched that with some results from his calculation. And now Trond Inge Rødland from DDS will show us something.
Yes, thank you, Bjørn. I am now going to show you our building services partner. I go into a drawing list, and the latest project is coming up. I create a new one and go into our module for ductwork. Open, for example, second floor, and continue with import the IFC module. If I can find it someplace. Here it is. So then the model is imported. We can see it is complete in 3 dimensions. We have a room list where we can see on, for example, bedroom number 1. And here is some IFC properties. From Ryoska, we have got some values, the sized airflow here. And we can choose which language we want to see the description in here. We continue with English today.
Can you go back there a little bit?
Yes. Bedroom number 1.
Yes.
The properties.
Yes.
Yes.
Please. Can we show the bottom line of this HVAC information? Okay, so we see that ArchiCAD was originally creating the space, but we see that there's, if you go up a little bit, we see BS Pro, Olof Granlund, has added information, so we can actually track who is supplying information to the model. And that's also quite interesting. I just wanted to mention that particular. Continue, please.
Okay. Then I continue with some ductwork. I start at 0 meter, make a click here, go on, and for example, Sorry, I take this once more. I start from 0 meter, and of course we have to go a bit up to, for example, 2.5, and select the way we want to go, and finish, for example, here with an air terminal, for example, 160 millimeter. Okay, and everything is, of course, in 3 dimensions. Quite similar, we have another module in the program for pipework, but I go now directly to the electrical part of the program, and maybe Björn want to say something about this before I
I want to say something, definitely. We said that we wanted to show IFC model being used from early stages with the maps and things and down to facility management, but we decided to do a little detour because IFC is not only between professions or disciplines, it's also within disciplines. So we will now work a little bit with electro and just show how fun that is within the electro industry, because there's so many things there that you wouldn't even believe if you're not inside. Please continue.
Yes, thanks. I continue with placing or defining first a new switchboard. I give it identical name and place the symbol with the snap function into the wall. I can anytime place a circuit pointer. There could be many switchboard, so we have totally control. Here it's H.1. Then I continue with placing some switches. Pick the correct type. I can rotate it, and it's snapped into the wall where I want it. Rotate it and place it. We have sockets. Pick the correct type. Place them where I want to have them. It's very fast. Okay. We need some lamps. We have a lamp point. It can be centered. Sorry, here. Oh. Do it once more. Centered between here and here. We need some heat. For example, 800 watt. It can also be centered under the window, like this. And we can now start defining circuits in our switchboard. Here we have an inlet and a circuit for light and socket. I can define some new one. Which one I want to draw, can I select and click Draw Circuit. Give the cable the correct dimension, give the correct cable type, and start from the switchboard. I go up to decide the height, for example 2.5, connect to the switch, and go up again, and continue connecting all my components. Anytime I can place circuit pointers. It's not only a blue line, it's an intelligent cable.
While you continue doing what you're doing, I just want to add that by showing this, what he is doing is what the contractors in Norway are doing every day, and mostly with this tool as well. He is actually building an information model inside the information model, because he started with an information model from the architect that's been through the energy analysis, and he's now putting this in. It looks like he's doing a CAD drawing, but it's actually providing a lot of information into this model. So he doesn't do anything special, since we will now use this as an IFC model. He just do what he has done for years. So please continue, Tony.
Yes, we can see on the circuit pointer that it's circuit number 2, cable number 2, it's a PVC cable, and the dimension we gave it. Then I go to the next part of our program, electrical partner, and go to the schematics part.
Du har ikke tid til det, Tony. Beklager.
5 seconds. We have our switchboard, we have our circuit list, and we have a single line diagram, automatic generated, and we have our circuit list here too. And if there are not so much time, I can go over now to a complete model of the project. Switch to it, I go into the electrical part, And we can see here it's quite complete. We can also see here the pipework and the ductwork in our total model. Here we can see everything. It's complete in, of course, 3 dimensions. And then I give all my information to the next one in the project by exporting the IFC file like this. Thank you very much.
So now, Okay. So now it's Paul Eskerud from Focus Software. He will be doing the tendering.
Hello. Good afternoon, everyone. Our challenge is to grab the information in the IFC model and move it from the graphical symbols and take out the intelligence in the model to generate structured descriptions based on classification systems like this. So I start with an empty project, and I will start to import the IFC file. I can import building elements, electrical components, HVAC components. I can also do some cross-checking to my own element library so that a specific wall type in the IFC model compares to the right one in my element library. So here we can generate structured descriptions and specifications based on building tables and the national classification codes. I also can do some pre-estimating. So I can import prices from my price archive. For instance, the average, and I can also adjust prices to a certain index. And then we'll just see that we have some prices in the project, approximately 40,000. So when I have done all this work...
Okay, can you stop for just a moment? Because I don't know if you got this. He was just importing an IFC file. And not only do we have that this is light fixtures of this and this type and so, but also says which space it's located in. Because, of course, it's combined these 2 building models. One from the architect with the space naming and everything, and then he plays these electrical components, and of course it's allocated to that space. So we'll see the number and which space they are in, and he can sort this in all kinds of ways. So, sorry, but just continue.
Thank you, Björn. Yeah, that's right. We have the different rooms here. So when I've finished making my specifications, I'll send it out for the bidding purpose. So I'll just export it again out to the file. And this is I send it out for price inquiry and generate the files. And I email them or publish them so the different contractors can do their biddings. And then I'll give the word to the next one.
This is Tor Nilsen from Nelfo. So he is now really eager to get this job. He really wants this job bad, so he will not make a bid for it. Come on, go for it.
Yes, I received this file from a consultant electro-engineer showing a description and quantity estimate for this project. I will now import it in my program, LData, check the description, calculate, check the result, and export the result back to the consultant electro-engineer. First, I create a new project. With some general thing. It's not important what I call it now. And then I will import the file from Now I must find the file. No, and it takes about 20 seconds before it's ready.
And when you're sitting there, that feels like an eternity, huh?
Yes, about 3 hours.
But we haven't had any paper yet. We've seen no paper so far.
Someone taking time? Now it's ready. Then I open the project. And here's what I got from Mr. Eskerud. And you see also here are the products that was drawn in DDS Electropartner. Then I must estimate the hours of work, manning requirements, the electrician piecework rate, and add on cost and profit. So here I will let's see what's happening here. And here I will show some screenshots from a previously calculated project where I've done my work to get this job. And I see the final result. Then I open the report database. Well, I want to see it here. And I will check the specification, including prices per unit, the summary of my tender, and a list of my chosen products. Here we see, and the summary of my tender is 45,438 Norwegian crowns. A little bit more than the estimate from Mr. Eskerud.
Okay.
No, I'm not ready yet. Then I go and export the file back to the electrician consult, electro-engineer.
Can we switch now?
Yes, now we can switch.
Okay. So now he's done his job. And well, IFC is also about decision making. It's making the right decisions. We saw with the windows, perhaps that was a good decision for the energy, and perhaps he will do a good decision for the price. I guess that's next.
Yeah, we hope so. What I've done in the meantime, I've just defined Nelfo as a tenderer. So what I like to do is to import Nelfo's prices into my project. So I just import it. I found his offer. And I can steer the prices to the specific tenderer. 19 prices. So what I like to do now is to do the same report. And I also like Nelfo's price and to see how it fits. 45,000 for 3.8, wasn't that your bid? So when I've done the tender evaluation and I choose a tenderer, what I would like to do that is to update the IFC file with the price information.
I think you should be cheaper, Tor, because you got all this data and you didn't have to do anything. So you should lower your price. You saved an awful lot of time.
And I want to update the model with the price information exactly from Nelfo. So that is what we do. Thank you.
Okay. And now we create a new IFC file, or I mean we enrich the IFC file. And just quickly to show that we enrich the data model all the time, Trond Inge will just click on some in a viewer setting.
Here is the file updated, and we can look at the preset for a socket. And the generic component we started out with has now get the unit price and a tag ID and a new preset owner, as you can see here.
Isn't that good? Huh? Fantastic. And then we want to move on to something a little bit different, but still keep within the electrical profession. And that's Eirik Selvik, and he is number 7. And number 2? No.
Yes, we have a program called FEBDOC, which is actually a program for calculating selection of cables and protection devices, and doing verification if then the electrical installation is in compliance with the national regulations in Norway. So what we do is actually that we import the IFC model, which I have got then from the electro partner. We import it, and of course we only extract the information that we need for the use of the FEBDOC, which is not the graphical model. It's not used. But we take the information we got, and that is mainly the circuit list from the out circuits from the switchboard. Already now I can see that because of this red device here, this red protection device, that something is wrong. But because it's red. But we need to do some calculations, and then we need to know the short circuit currents at the origin of the installation, and that is not available by the IFC model. So I have to provide that information, and then I just click there, and we have some default values which I just accept, and then okay, and then FEBDOC verifies all circuits if they are in compliance with the regulations, and of course there is still a red device, so I have to look there and see what's wrong. And I click there on the device, and here is a red label here down here saying that sorry for the Norwegian, but it actually says that the rating current of the protection device is too high according to the regulation, and referring to a specific clause in the regulation. I think that Trond Inge has said that he has to use 1.5 square millimeters cross-section of the conductor and have a 13 amps rated protection device, and that's not allowed in Norway when you have closed. So that we have to do something. So there are two things we can do. We can either reduce the nominal current of the protection device, or we can go to the cable and say that, well, we increase the cable to 2.5 square millimeters. I prefer the last one because that's better for the electricity assurance. And of course, then I go to see the protection device again, and it's okay. It's okay, and then we can just accept it. FEBDOC has one disadvantage according to what we're talking here about generic products. FEBDOC works with manufactured products. It works with manufactured cables, and it works with manufactured protection devices. That means that we have a database of protection devices from covering all the major, suppliers of manufacturing of protection devices in Norway. It counts more than 5,000 different devices. From the electro partner, we got this information without any selection of the manufacturer, but he has indicated that it should be the specific type. So what we did was actually during the import, we selected type manufacturer and a type of the manufacturer to be applied. At this prototype, it is hard-coded, but of course there should be a selection because of the manufacturer you are going to use. So that will be available. But now, as I have selected the manufacturer, if you see here, we have selected a Siemens S5SYB, 54B. So then I can put this information back, and I export this back into the